This video is for the explicit formulas of arithmetic sequences and geometric sequences. So what we're going to start with is what's called finding the nth term. We're going to write a formula that we can use to find any term in a sequence. So the nth term of an arithmetic sequence with first term a1 and common difference d is given by the formula an equals a1 plus n minus 1 times d, where n is a positive integer. So we're going to write an equation for the nth term of the arithmetic sequence, negative 12, negative 8, negative 4, 0. So our first term, a1, is negative 12. And then we need to find the common difference. What did they do to negative 12 to make it a negative 8? And so what you can do is you can subtract negative 8 minus negative 12, and we get a 4, and then you can check the next one too, negative 4 minus negative 8. That gives us a positive 4, and you can even do the last one for good measure. 0 minus 4, or negative 4, gives us a 4. So the d value, the common difference, is 4. So using this template, a of n is going to equal a1, negative 12, n minus 1, and then the d value is this 4. Now from here what we need to do is we need to simplify this down. Sorry, there should be a plus sign there. So to do that, let me grab a blank sheet of paper here. Alright, so we've got negative 12 plus n minus 1 times 4. So the first thing I'm going to do is I'm going to distribute this 4 out. So I've got negative 12 plus 4n minus 4, and then I'm going to combine these two like terms. So I'm going to have 4n, and then negative 12 plus a negative 4 is going to give me negative 16, so I can just write that as minus 16. So simplified, this formula would be a of n equals 4n minus 16. Okay? So up here on the your turn, we're going to do the same thing. So 150 minus 78 gives me 72. So we know a1 equals 78. And then the d value, let me try another one, is 72. So I would have a of n equals a1 plus n minus 1 times 72. Distribute out, so 78 plus 72, 72n minus 72. Combine my two like terms here, so 72n, and then I'm left with a positive 6. So I would have a of n equals 72n plus 6. Okay, so now the next one, so negative 30 minus negative 14 gives me negative 16, negative 46, minus a negative 30 gives me a negative 16. So a of 1, that's our first term, is 14. Our common difference is negative 16. So I'd have a of n equals negative 14 plus n minus 1 times that negative 16. So minus 16n plus 16, negative 16n. So negative 14 plus 16 is a positive 2. So a of n equals negative 16n plus 2. And then with fractions, you still do the exact same thing. So I've got negative 19 over 45 minus alpha y1, 8 over 45. So here for this one, my first value is 8 over 45. My d value is negative 3 over 5. So I would have a of n equals negative, or not negative, 8 over 45 plus n minus 1 times negative 3/5. So 8 over 45. Distribute that negative 3/5 out. So minus 3/5 in, and then plus 3/5. Combine like terms. So a of n equals negative 3/5 in, and then, let's see, alpha y1, 8 over 45 plus 3 over 5 gives me a positive 7/9. So here I would have a of n equals negative 3/5 in plus 7 over 9. All right, so now using these. So here's how these types of questions are asked. Find the fifth term of the sequence described by the explicit formula a of n equals negative 6 plus 17n. So the first thing we're going to do is we're going to substitute the 5 for the n in the formula. Okay, so a of n is now going to be a5 equals negative 6 plus 17 times 5. So that n becomes a 5 as well. So a of 5 would equal negative 6. 17 times 5 is 22. A of 5, negative 6 plus 22 is a positive 16. So what that means is the fifth term of this sequence, I could plug every number in, 1, 2, 3, 4, all the way up, and I could write this sequence. But if I just want to know what the fifth term is, it would be 16. Right? So now, given the explicit formula a of n equals 7 minus 4n, determine what term negative 25 is of the sequence. So in the formula for the nth term, we're going to substitute the negative 25 for a of n. So for this part, so where a of 5 equals 16, we want to know when this value, what this number would be when this value is negative 25. So we would have negative 25 equals 7 minus 4n. Now we just have an equation to solve. Okay, so we'd subtract 7 from both sides. Negative 25 minus 7 is a negative 32. Negative 4n. Divide both sides by negative 4. Negative 32 divided by negative 4 is 8. These cancel. So, negative 25 would be the 8th term of that sequence. All right, so geometric. So for geometric, the explicit formula looks a little bit different. So the nth term of a geometric sequence with first term a1 and common ratio r is given by the formula a of n equals a1 times r to the n minus 1, where n is any positive integer. A of 1 cannot equal 0, and r cannot equal 0. So we're going to write an equation for the nth term of the arithmetic sequence, negative 6, 12, negative 24, 48. So we know our first term, a1 is negative 6. Then we have to decide, what did they do to negative 6 to turn it into a 12? So you can work backwards the same way. You can do 12 divided by negative 6, negative 24 divided by 12. And so our r value, our common ratio here, is a negative 2. So using our template, a of n equals a1 is a negative 6, r is a negative 2, and then n minus 1. Now we can simplify this one down. So what we have is we've got negative 6, and I can distribute this out. Okay? So what I mean by that is I can make it negative 2 to the n, and then negative 2 to the negative 1. Okay? So what this does, negative 2 to the negative 1, negative 2 to the negative 1. What it does is it makes it a reciprocal. So negative 2 to the negative 1 turns into negative 1 over 2. It flips it. So what I have now is negative 6 times negative 2 to the n, and then this is now negative 1/2. And what I can do, these are like terms. I can multiply these out. Negative 6 times a negative 1/2 gives me a positive 3. So what I have is 3 times negative 2 to the nth power. So a of n equals 3 times negative 2 to the nth power. And that should look really familiar to you. That is an exponential function. Okay, here we go. So a1 is 98. And then, let's move that. 686 divided by 98. 4802 divided by 686. So my R value is 7. So I would have A of n equals 98 times 7 to the n minus 1. So that's unsimplified. If I work this out, I would have 98. 7 to the negative 1 is 1/7. Okay, so I don't want you to get confused with that negative sign in there. 7 to the negative 1. And if I do alpha y 4, okay, that negative 1 as an exponent flips the number into its reciprocal. And then I would still have 7 to the n. So 98 times a 7th is the same as 98 divided by 7. So I would have 14 times 7 to the n. Okay. All right, on the next one here, a of 1 equals negative 20. R equals 40 divided by negative 20. So negative 2. That's our R value. So a of n equals negative 20 times negative 2 to the n minus 1. So negative 20, negative 2 to the negative 1 is a negative 1/2, and then times negative 2 to the n. So negative 20 times negative 1/2 is a positive 10, and I still have the negative 2 to the n power. So unsimplified, I've got negative 20 times negative 2 to the n minus 1. Simplified, I've got 10 times negative 2 to the nth power. All right, fractions. All right, alpha y1, 1/6 divided by alpha y1, 1/3. I get a 1/2. Oh, it should be a negative 1/2. That should be a negative. I'm sorry. Try that again. Second answer, negative. So, and you can always try it out. 1/3, negative 1/3. Keep doing that. Times negative 1/2. I don't know if y'all saw what I did. I used the subtraction sign instead of the negative. Is 1/6. So we know our R value is negative 1/2. So A of 1 is negative 1/3. R value is negative 1/2. So A of n equals negative 1/3 times negative 1/2 to the n minus 1. So we would have negative 1/3. Now, negative 1/2 times a negative 1. It's going to flip it. So that's going to become just a negative 2. And then we still have negative 1/2 to the n. So, negative 1/3 times 2, times a negative 2 gives me 2/3. 2/3 times negative 1/2 to the n. So unsimplified, negative 1/3 times negative 1/2 to the n minus 1. Simplified, 2/3 times negative 1/2 to the n power. All right, so using these, we use them the same way. So down here it says find the fourth term of the sequence described by the explicit formula. A of n equals -3/8 times 8 to the n. So we would substitute 4 for all the n's. So we would have A of 4 equals -3/8 times 8 to the 4. So A of 4 equals -3/8. 8 to the 4th power. 8 to the 4th. It's 4096. And then if I multiply that by a -3/8, I get -1536. So the 4th term would be -1536. And so we don't have usually with geometric like we do with the arithmetic where it says which term is this number. So this one says write the first 4 terms of each sequence. So for this one, we would do 6 times 10, and so the first term would be, we'd plug a 1 in there for the n, so we would have 1 minus 1. So our first term would be 6, and we go and do it again. So instead of a 1 though, instead of n, we'd put a 2. So that's 60. Do it again, change it to a 3, and we get 600, and you can probably see the pattern that's forming. And this one would be 4. So the first 4 terms, we'd plug 1 through 4 in there for n. Okay, so on the next one, 5/6 times 6. Now this one just says to the n, so this formula has already been simplified. So we just plug a 1 in there for n. Ooh. I didn't math right or something. So we've got a 5. I don't know how I did that. Plug a 2 in there, we've got 30. Plug a 3 in there, and we've got 180. Plug a 4, and we've got 1080. And then finally, here's our last one. 3/4 times 1/4. Try that again. 1/4 to the, okay, so we've got n minus 1 again, so we would do 1 minus 1. So our first term is 3/4. Change it to a 2, we get 3/16. Change it to a 3, we've got 3/64, and then change it to a 4, and we've got 3/256.